The Unit 1 Day 1 notes has an activity that goes along with it. So what I'll do is I'll do this part up here, which is our introduction, and then you can do the activity and pause the video while I do the activity, unpause the video, and then we'll be at the summary section of it. So let's look at this function called an absolute value function, and you know it's an absolute value function because these bars right here are absolute value bars. And you might remember from Algebra 1 that the absolute value of a number is how far away a number is from 0. So the absolute value of 3 is 3, and the absolute value of -3 is also 3, because the distance from -3 to 0 on a number line is 3. So what we're going to do is we're going to draw a graph of the mother function or parent function, and our x values are going to be -2, -1, 0, 1, and 2. Our y values, well, the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. We can plot those points now. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. The absolute value function will look like a V. And the graph has something called a vertex, and that's the pointy part. The pointy part in here is right there, so that's the vertex. The coordinates of the vertex in this mother function is 0, 0. And you notice that you have two lines that make up this absolute value function, or this V. You have this line in light blue, and you have this line in red. So the slope of the light blue line, if you look at it, if you're going from left to right, we're going down 1, right 1, down 1, right 1. That gives us a slope of -1 over 1, or just -1. Looking at the red part of this, our slope going from left to right is up 1, right 1, up 1, right 1. So +1 over 1, or just 1. So you'll notice that for an absolute value function, when we look at the two parts of the V, one has a negative slope, one has a positive slope. And the graph in this case opens upwards. Up. And the domain, remember, domain is the x values. You can plug in any number for x and take the absolute value. So the domain is all real numbers, or you can write it as -infinity, infinity, because that means every number from -infinity to +infinity. The range, or the y values, that's different. The smallest y value we have is right here at y equals 0, because both sides of this function are going up. So the range is 0, infinity, and we use a bracket because 0 is included. We have a point at 0. Okay. Right, so the first thing we're going to do is explore what does the a value do. The a value is in front of the absolute value bars. And if the actual numeral is bigger than 1, so even if it's -3, okay, that number in front is 3. The numeral is a 3. Or think about it as, if the absolute value of a is bigger than 1, we call that a vertical stretch, because it looks like the function is being pulled up from that mother function. It looks skinnier. Looks skinnier. So that's when the a value, the absolute value of a is bigger than 1. If it's less than 1, so like 0.5 or negative 2/3, we call that a vertical shrink. It looks wider, like the V is very opened. If a is negative 1, now look, it says equals negative 1. Just if it is negative 1, it is a reflection over x-axis. And we could combine that. We could have negative the a value be negative 2, which would be a vertical stretch because 2 is bigger than 1, and a reflection because a is negative. And if a is just regular 1, there is no shrink or stretch or reflection. All right, now let's look at the next page. It says, for the following example, graph the function and compare with the parent function. So y equals negative 2x. So if you compare that to our mother function up here, and with the vertex at 0, 0. So the vertex is still going to be at 0, 0. But because it's a negative 2, what we do is we go from the vertex down 2 and left 1, and then from the vertex down 2 and right 1. So then our V is upside down. And then when we compare it, we always do what is called RST. R tells us, or asks you, is there a reflection? Yes or no? Yes, there is a reflection. Yes. Over the x-axis. Shrink or stretch, there is a vertical stretch because the number in front is 2. Translation, we haven't talked about translations yet, but even if there is no translation or any of these transformations, you're going to write none if there's not there, because I want to know, do you recognize there's no translation? If you leave it blank, then I'm not sure if you know that there's no translation or if you forgot that you need to look for it. So you always need to write none if there isn't one of these transformations. So now the effects of h and k. So h is the horizontal movement, and it's always the opposite of what you see, and k will move the graph vertically up and down, and it is exactly what you see. So what this means, when we add a number on the outside, the graph moves up, that vertex moves up. If we subtract a number on the outside of the absolute value bars, the graph goes down. If we add a number on the inside, it moves in the opposite of what we would think, so it's going to move left. And if we subtract a number on the inside, the graph moves, that vertex moves right. So that will help us graph our vertex, and then once we have our vertex, we can use the a value as the slope of our two lines, two parts of the absolute value v, to graph our function. So let's look down here at this problem, this example here. So we're going to graph the function and then compare it. Well, when we see this plus 2, that means our graph is going to be shifted left 2. And this minus 4 means we're going to be shifted down 4. 1, 2, 3, 4. Now, the number in front, there is nothing there, so it's an invisible 1. that means our graph is going to go up one, left one, up one, left one. That's going to be one side of our graph, and the other side will go up one and right one, and our graph will look like this. We're not going to compare this because we're going to do the summary down here. So summary, this is the terminology we're going to use to compare things. So if there is a reflection, there's a reflection if this A value is negative. If A is negative. So that's what R would stand for when I would ask you to compare. R is for reflection. Is there a vertical stretch or a vertical shrink? Well, a vertical stretch happens if the absolute value of that A value is greater than 1. So if it was a 5 in front, you would have a vertical stretch. If it was a -3 in front of the absolute value brackets, that would still be a vertical stretch. A vertical shrink happens when the absolute value of that A term is less than 1. So 0.5, -2/3. You would have a vertical shrink. The translation, you are going left or right, H units, and you are going up or down, K units, whatever that K number is out here, and that H number on the inside. So let's look at some examples now on the next page. And when I ask you to compare now, I am going to be expecting to see R for reflection, S for shrink or stretch, and T for translation. Now, if a particular problem doesn't have a translation, a shrink or stretch, or a reflection, then you can just say none. How I like to start these problems is to graph the vertex first. We see +2 on the inside. That means we're going to be shifted left 2. And -3, so we're going to be shifted down 3. There is my vertex. And if you want, you could write for the translation that we are left 2 and down 3. Or you can wait until we're done graphing and write this stuff down. Now, our A value is +1/2. So that means there is no reflection. A shrink or stretch, you do have a vertical shrink because 1/2 is less than 1. So we have a vertical shrink. And that 1/2 means we're going to go up 1 and left 2, up 1 and left 2, and then from the vertex up 1 and right 2, up 1 and right 2. So you see that our absolute value function, our V, got shrunken down. This one over here, we have a -1, so we're going to go right 1, and a +2 means we're going to go up 2. So there is our vertex. It is right 1 and up 2. We have a negative in front, so that means we are going to have a reflection over the x-axis. And then when it comes to shrink or stretch, that 3 means we're going to have a vertical stretch. So from our vertex, we're going to go down 3 and left 1, down 3 and left 1. And from our vertex, down 3 and right 1, down 3, right 1. So this is what our absolute value function will look like here. Now here we're going to write the equation from the graph. So y equals, I see that we have a positive A value because this V is open upwards, and our slope, up 1, right 1, up 1, and right 1. So we have an a value of positive 1. You don't have to write that down because you could just leave it as an invisible 1. Then our vertex is right here at -1, positive 2. So that means we need to have +1 on the inside of our absolute value bars and a +2 on the outside. And like I said, you don't need to have this 1 there. It's not wrong if you do. It's just most people don't write that in. Okay, the next one, y equals. We are open downwards, so we know we're going to have a negative sign in front. And our slope, we're going down 2 and right 1, down 2 and right 1. So that means a -2 is out in front. And our vertex is at +2, 3, meaning we need to have x -2 on the inside and a +3 on the outside, because we're shifted right 2 and up 3. The last one here, let's start with y equals. We see we're opened upwards, so the a value will still be positive. And our slope, we're going up 1 and right 2. So our slope is 1 over 2. And the absolute value of x, our vertex is at -2, -3. That means we have to have x +2 on the inside and then -3 on the outside. When we're writing our equations or dealing with the left and right shift, it is always the opposite of what you would see. Our vertex was at -2, -3. So we need to have x +2 in those absolute value bars. On the outside, our k value, it is always exactly what you see. You can see that -3, -3, +3, +3, +2, +2, and then -1, +1, +2, -2, -2, -2, +2. So you use that highlighting to help you out if you need to at first. Last question here. Write an equation of an absolute value function with the reflection in the x-axis. So this part right here means a is negative. A vertical stretch, so that means the absolute value of a is greater than 1. And a translation so that the vertex is in the 4th quadrant. All right, and if you have forgotten what the 4th quadrant is, we have 1, 2, 3, 4. We want our vertex down in this area. So x is positive and y is negative. And I gave you guys that hint right here. Right, y equals. And there are multiple correct answers. So let's start with a negative in front because we have a reflection. And we just need any number in front that's bigger than 1. Let's go with 7. That was one of my hockey numbers. Let's go with that. X. Now, if we want to be in quadrant 4, that means we need to have a negative sign right here because our vertex has to have a positive x coordinate. So let's go with 4. Why not? Now the y value of the vertex is negative, so that means we need to have a minus some number out here. Let's go with 9. The vertex of this function is +4, -9, which is in quadrant 4. Now, if you wanted to, you could have just said, let me pick a point in quadrant 4 first, and then create my equation based on that point. Either way works. So I hope that you're getting an understanding of the effects of what A, H, and K do in our absolute value functions. It is very important to understand this because A, H, and K are something to deal with, that's something that we're going to deal with all year. So thanks for watching. Make sure to smash that like button and subscribe.